Our third objective for this section is talking about the process we go through to multiply and divide fractions. So if you look back to the previous section, we took a single fraction and turned it into a multiplication problem. We put a 3 times 4 over a 5 times 4 to see where our ones were. And if you think about multiplication, 3 times 4, 4 times 3, both have the same answer. So even if those numbers were reversed, we would still have, even if we had 3 times 4 over 4 times 5, we would still have a way to get that magic 1 out of there. The reason that I'm saying that is because if we're multiplying the fractions 3/4 times 4/5, we can still remove a 1 the same way that we were up here when we were reducing a fraction to lowest terms. So let's look at some examples of that. We want to get rid of common factors. And then multiply whatever is still left. So if we look at this first one, 5, 9, the only thing we could break 9 up into is a 3 times 3. 7 and 4, 7 won't get any smaller, 4 could be a 2 times 2, but we don't have any 7s or 4s or 2s on the top, and we don't have any 5s or 9s or 3s on the bottom. So there are no common factors. There is nothing in common that we can reduce from this fraction. So we're just going to multiply the numerators together. 5 times 9 gives us 45, and 7 times 4 gives 28. Looking at the next problem, 8/5 times 25/4, we've got a lot of 1s we can get rid of here. The 8 is really the same thing as 4 times 2, so that lets us get rid of that pair of 4s. And 25 is the same thing as 5 times 5, which lets us get rid of a pair of 5s. So our numerator is going to be 2 times 5, which is 10. When we canceled these numbers out, 5 was canceling out with this 5 because this 5 is a 5 times 1. So really the 1 is still there, and here as well, when we get rid of the 4s. 1 times 1 is 1. But since this is ending up in our denominator, and a whole pizza, 10 pieces of whole pizzas, is the same thing as just having 10 pizzas. So if your 1 ends up in the denominator, it's okay to get rid of it. The same is not true if it ends up in the numerator, because a tenth of a pizza is not the same thing as 10 pizzas. So be aware of that. Only get rid of 1 if it's on the bottom. You do a multiplication problem and end up with a 1 on the top, you need to keep it there. Okay? Dividing fractions is very similar to multiplying fractions. The only change is that we're going to find the reciprocal of the second fraction. And for purposes of this course, I'm not even going to make you memorize the word reciprocal. Many of you may remember this from a previous class as being copy.flip or copy.flop. You take the second fraction and turn it upside down. So we're going to turn 3/10 into 10/3, and then it becomes a multiplication problem. So flip second fraction, then multiply. So our 5/11 divided by 3/10 is going to become 5/11 times 10/3. And you'll notice with this, back when there was a 5 and a 10, it looks like I can cross something off. That getting rid of common factors only works in multiplication problems, not division problems. So we have to do the flipping first before we look for common factors. And now that the 10 and the 5 are both on the top, we don't have a common pair that we can combine. So we're just going to multiply the numerator and multiply the denominator. The second one looks like it might be a little harder to do because we said you need to flip the second fraction, and it looks like we don't have a second fraction. We have a whole number here. But for the same reason that it was okay to get rid of the 1 up here, it's okay to put a 1 in down here. So I'm going to make this 4 into a fraction by putting a 1 under it. Now I have a second fraction to flip, so this becomes 2/3 times 1/4. And looking at my new improved problem, I see a pair of 2's I can take out. Dividing 4 by 2 will leave me with 2 and a 1 on the top, so that when I multiply through, I get 1 times 1 is 1, and 3 times 2 is 6.